Once again, we're looking at solving a system of equations by elimination. Our first step is to put both equations in standard form. Ax plus by equals c. So our first equation is already in that form. 5x minus 3y equals 15. To put our second equation into that form, we would subtract 5/3 x from both sides, which would give us negative 5/3 x plus y equals negative 5. And then we would eliminate the fraction in our second equation by multiplying both sides by our LCD, which in this case, since we only have one, we would multiply both sides by that denominator, which is 3. That then gives us the equations 5x minus 3y equals 15, and 3 times negative 5/3 is negative 5x plus 3y equals negative 15. Now you should notice that if we multiplied either equation by negative 1, we'd end up with the other equation. But what we'll do is simply add the equations. Negative 5x plus 5x is 0. Negative 3y plus 3y is 0. And 15 plus negative 15, again, is 0. So this is a true statement. So what does it mean when we solve and end up with a true statement and the variables fall out? So with this true statement, what that means is that the equations are consistent but dependent. So we have consistent but dependent equations. And what this means is that they essentially represent the same line. If we solve for y in the first equation, we'd end up with y equals negative 5 plus 5/3 x. So when we clear the fractions, add together, we end up with a true statement, which means that the solution is all real numbers, or there are infinitely many solutions, and those solutions would be all points on the line y equals negative 5 plus 5/3 x, or in slope-intercept form, or y equals 5/3 x minus 5.